Yeah, hi, this is Jim Dillingham from DZ Engineering. I'd like to go over with you our modeling capabilities here at DNZ. We've been drawing our projects in both 2D and 3D for the last few years. We've been utilizing the 3D modeling to help us achieve a greater understanding of some of our projects. I'd like to go over with you some of the ones that we've done in 3D modeling. The one on the screen here is one that we entirely modeled, throwing in every element of the structure into the model. It takes an additional amount of time to go to this level of detail, but in regards to complexity, it really ends up showing all the complexities of the project clearly and helps us as well as others understand how the structural elements are interacting with the entire structure. In the modeling program, with everything inputted, all the detail section cuts are taken straight from the model, and no matter where you cut the section, it represents the geometry straight from the model, similar to this detail. We're also able to input structural analytical models into the drawing model. In this case, we did that with a steel frame that was a cantilever element supporting both lateral loads and gravity loads. Here's the CAD version of the detail for the frame, and then this is the analytical model that was actually generated with a program and then interacted with the model and inputted all the elements from the program into the model. And this is that frame under construction. We've also used the model in the past to really help identify levels of within a project. This is a stair going down to the beach in Santa Barbara area, and it's an existing stairway that we rebuilt with the help of an architect. The architect gave us the survey which identified the platform heights, and then with that we were able to model the entire stair and arrange for it to where we got the geometry correct on the rise and run for each of the stairs, and we're able to meet code by keeping all the rise and runs from each stair element the same given where the platforms were located. These were existing piers, and the platform heights were able to be adjusted up and down, but not in plane on the site itself. And this is the project under construction. Due to those elements of modeling, the construction went very smooth. We've used the modeling program to figure out complicated roof planes and how they interact with each other. This is an example of that. This is a high-end custom home with a bunch of different roof planes coming together. We've got towers, we've got different plane pitches, and the model really enabled us to get them all to plane in together correctly and then show appropriately on the 2D drawing program that we use to represent the roof framing. This is another project that we've done. This was an addition, a fairly large addition. I think it's about twice the size of the original house. Here's the original house. And we came in with a bunch of different roof planes, used this model in order to make sure that they didn't interact with each other. You see we have a tower, we have an upper roof of the addition, we have an addition to the existing house here, and they all interact with each other. We used the model to make sure that they weren't interfering and that watershed was going to be successful. This is the project under construction. You can see how the tower was able to come in like the model and just be close to the existing upper roof, but then not touch it. So without having the model as a tool, that would have been difficult to provide that level of accuracy. This is another project that we've done in the past. This was a winery. We did both the steel building and a wine cave. The model ended up working out quite well with the steel building and interacting with these steel trusses, and then later we used it to design the wine cave into the hillside, being given the civil survey we were able to input that into the model and then design this to where everybody could see exactly what the winery would look like. You can also use the model to give a photorealistic rendering, and that's what this is right here. We tend to use the model sometimes on projects in increments, and this was one where we just used it on one particular area of the project in order to figure out challenging geometry just for one area that needed it. The other parts of it we were able to run in our standard AutoCAD 2D program without any problem. But you can see how we use the program here is quite useful. We had an existing condition that was remodeled on top of a remodel, and the architect was asking us if there's any way we could raise the ceiling height to get a central room look, you know, sort of pop-up ceiling that would be centered on the whole room. Well, in order to do that, we bumped it into the model and were able to get the tight geometry, and you can see we're able to get the existing plane and then come in with our new planes of the ceiling and get right tight within inches of popping through the roof. This is the final look of what we were able to achieve. So the ceiling has a pop-up of a foot that's centered on the room, and that pop-up is, you know, literally within inches of coming out of the roof. If you have any questions about our capabilities, please give us a call. We've been invested into 3D modeling now for quite a few years and are able to do it at any level of a project with complete 3D modeling of the entire project or just partial to give us benefit in certain areas that might need it. Thank you very much.